Now we are moving on to the next section, section B. Section B consisting of only 2-mark questions. And in those 2-mark questions, we will be having two optional questions. Two questions will be there, having internal choice. So these questions will be from chapters pair of linear equations in two variables, introduction to trigonometry, triangles, circles, and we'll be having one question from area related to circles. And all the questions that we were discussing so far, MCQ questions, and in those questions, certain questions can be asked for 2 mark. So you need to expect those questions as 2-mark questions as well. And in the last video, in the last part, I have included 2 questions that can be asked for MCQ or in section B. So just focus on those questions. And now we'll be moving on to a few questions, only 5-6 questions. That's very, very important. I'll be discussing in this section. And just go through the video. It will be really helpful for you. So this question will be starting with section B. In this, we'll be starting with a question from linear equations in two variables. So the first question, it's a 2-digit number is 4 times the sum of the digits. It is also equal to 3 times the product of the digits. Find the numbers. So since it's a 2-digit number, it will be having 1 digit in the tens place and 1 digit in the ones place. Let x be the digit in the tens place, y be the digit in the ones place. So 10x plus y will give you the number. This is actually the number. For example, if it is 72, it can be written as 70 plus 2. The same way, since 7 is coming in x place, 2 in y's place, so 72 can be written as 70 plus 2 in this order that can be represented. So according to the first statement, 4 times the sum of digits. So a 2-digit number is 4 times the sum of digits. So 10x plus y is the 2-digit number. That is 4 times the sum of digits means 4 into x plus y. X and y are the digits. This is the first relationship. And the second relationship they have given, it is also equal to 3 times the product of the digits. So 10x plus y is equal to 3 times x into y. So now we have two relationships. Based on this, we can solve this question. Now look into this. So you can rearrange the first and you will be getting a linear equation in two variables. Here, from first you can get 10x plus y is equal to 4x plus 4y. Then rearrange this in such a way that 10x minus 4x minus 4y plus y will give you 0. So from that, you can get the first relationship like 10x minus 6x will give you 6. 10x minus 4x will give you 6x. Minus 4y plus y will give you minus 3y equal to 0. So that means you'll be getting 2x minus y is equal to 0, or you can write 2x equal to y. So 2x equal to y is a relationship that you'll be getting from the first equation. So you can substitute for y as 2x. Now you'll be getting 3x into 2x 10x plus y. Okay, wherever you find y, you can replace that with 2x. 10x plus 2x, y can be replaced with 2x. So that can be written as 10x plus 2x can be rewritten as 12x. So 12x equal to 3x into 2x, that will give you 6x square. Okay, so 1x will get cancelled from both sides. So finally you will be getting x is equal to 12 by 6, that is 2. So on getting x as 2, you will get y. Okay, so y is equal to 2x. So y will be getting as 2 into 2, 4. So now you have y and x, but we assume x as the tens place digit and y as the ones place digit. And you have the tens place digit x as 2 and the ones place digit as 4. So your number will be 24. xy will be your number, and that is 24. The next question from section B is from trigonometry. So introduction of trigonometry will be having one question for 2 mark and one question for 3 mark. So certain questions for 3 mark will be from identity related questions, and this is one question that's the application of identity, but this is a simple question. You need to show that tan raised to 4 theta plus tan square theta is equal to sec raised to 4 theta minus 6 square theta. And from the LHS, if you are taking the LHS first, tan raised to 4 theta plus tan square theta, you can take one tan square theta outside, so that it can be written as tan square theta into tan square theta plus 1. But we know the identity, 6 square theta is equal to 1 plus tan square theta. So 1 plus tan square theta can be replaced with 6 square. So I'm rewriting this as, in place of this tan square theta plus 1, I'll be writing sec square theta. And tan square can be written as sec square theta minus 1 is actually tan square theta. So this can be replaced with sec square theta minus 1. Now expand this, you will be getting sec raised to 4 theta minus sec square theta. That's your RHS. So hence proved. So this question is again from trigonometry, but this is actually the T ratios of specific angles. We have cot 30 here, tan 60 is given, sin 60 is given. We know the values of these specific angles. I've already mentioned in one of those videos. Just go through this. 0, 30, 45, 60 and 90. For these angles, when the value of theta, sin theta, the value will be 0, 1 by 2, 1 by root 2, root 3 by 2 and 1. In the reverse order, if you're writing this, you will be getting the value for cos. So that will be 1, root 3 by 2, 1 by root 2, 1 by 1 by 2 and 0. Sin by cos will give you tan. So take the difference and you'll be getting enough time for finding specific values of T ratios. But since you must be able to understand the values of these angles by now, since we are writing the exam in 2-day time, so you can substitute the values of this. I'm taking the LHS first. I'm taking the LHS. LHS value is root 3 plus 1 is already given there, into 3 minus cot 30. Actually, tan, the values are 0, 1 by root 3, 1, root 3, not defined. In the reverse order, if you write this, we'll be getting the value for cot. Since cot is actually the reciprocal, for cot 60, the value is 1 by cot 30, the value will be root 3. So 3 minus root 3 is the LHS. Now, we can expand this. Root 3 into 3 will be 3 root 3. Root 3 into root 3 will give you 3 minus 3. Here 1 plus 3 will be there. Again minus root 3 is there. So minus 3 plus 3 will get cancelled. 3 root 3 minus root 3 will give you 2 root 3. So your LHS is 2 root 3. Again, you can give the values in the RHS. So in RHS, take the RHS separately. Tan 60 is, we have already written the value for tan 60. Tan 60 is root 3. So that is root 3 whole cube minus 2 into sin 60. 2 into sin 60 is 2 into root 3 by 2. So these 2's will get cancelled. Root 3 whole cube will give you 3 root 3 minus root 3. Again, the value will be 2 root 3. So now we are getting LHS is equal to RHS, hence proved. The next question, it's from triangles. In the figure given below, triangle ODC is similar to triangle OBA. It's given in the question, angle BOC is equal to 125 degree, angle CDO is equal to 70 degree. Find angle DOC, angle DCO and angle OAB. These are the angles that we need to find. So only thing that's known to you, it's BOC, it's given in the question as 125. Also given CDO as 70 degree. This angle is also given. So these two lines formation, nothing is mentioned about whether they are parallel or not. If they are parallel, we can say by alternate interior angle, so and so. But we know certain things related to the angles. Since these angles, this is a straight line, this angle with that be x, these two will together form a straight angle, that is 180 degree. So that's why we can find angle DOC by 180 degree minus angle BOC. BOC is 125, so 180 degree minus 125 will give you 55. So that's angle DOC. That was one angle that we need to find. So that part is over. And coming to angle DCO. DCO, it's this angle, DCO. So now we know this angle. This angle we got as 55 degree. This is actually 55 degree. So by using the angle sum property of triangle, we can find the remaining angle in that triangle. So this is 70, 70 plus 55. Together we'll be getting 125. So 180 degree minus 125 will give you 55 degree. So these two angles we found using the angle sum property and the straight angle property that we learned in the lower class. And coming to angle OAB. For finding angle OAB, this is the angle OAB. For finding that, we can consider the similarity of triangle ODC and OBA. Since ODC is similar to triangle OBA, we can say that angle OAB is equal to angle OCD. So OCD we already found, that's actually 55 degrees. So we got all the angles connected to this question. So this is a 2-mark question. It's very important question. The triangles being shown in a different way, and we are applying the similarity criteria in this question. So the next question is from circles, a 2-mark question. From circles, you can expect one 3-mark question too that we can discuss later. So out of the 2 concentric circles, the radius of the outer circle is 5 centimeter, and the chord AC of length 8 centimeter is a tangent to the inner circle. Find the radius of the inner circle. That's the question. So we have 2 concentric circles with the same center, and we need to find the radius of this inner circle. And we know one thing, it's given in the question that the radius of the outer circle is 5 centimeter. And one more thing, this is a chord, and the radius will meet the chord that is tangent to the inner circle at 90 degree. And considering these two, this chord and these two length, that will be same, will bisect, so that will be 4 centimeter each. And coming to the question, now we have the hypotenuse of a right triangle as 5 centimeter. This leg is 4 centimeter. We need to find this radius. That's actually by using the Pythagoras theorem, we can find that. So in this question, r is equal to square root of 5 square minus 4 square. So that will give you 25 minus 16. So that's root 9. We'll be getting 3. But we can find the answer since it forms the Pythagorean triplets. And we are using one more property here. The perpendicular from the center to a chord will bisect the chord. Based on that, we got this 8 centimeter chord divided into 2 4 centimeter chords. So you need to mention that property along this question while solving the question. The perpendicular from the center will bisect the chord. Since AC is a chord of length 8 centimeter, that's how we'll be getting this triangle with one leg as 4 centimeter.